All right, so we are in geometry. Today's date is Monday, April 15th. We've just come back from a nice weekend. So write down the date, April 15th, 2019. Make sure your name is on your notes. And let's get some vocab again. Not nearly as much vocabulary as Unit 14, but here we go. So, distribute. Who can show me an example? You don't even have to give me the formal definition. Give me an example where you would need to distribute. Go for it, India.
We have a 4, then parentheses, and we have a 3x plus 1, and then parentheses.
Yep, that would be an example where you need to distribute. You distribute the 4 first into the 3x to get 12x. And then next you would distribute that 4 into the 1. 4 times 1 would give you 4. Perfect example, India. Thank you. You can turn in your card. So that's distributing. That was Unit 14. All of Unit 15 is going backwards of Unit 14. So if you know what Unit 14 is, then you can go backwards. Let's come back over here. Make sure that I'm doing this as well. So India, you are in. And I'll get the marbles up here as well. So factoring, that's just backwards distribution. That's exactly the definition that I'm going to be writing here. So India's marble is in. So factor, that is backwards factoring. That means somehow if I give you 12x plus 4, you need to give me 4 times the quantity of 3x plus 1. I'm giving you the answer, you're giving me the problem. Okay, so, and greatest common factor. This is definitely from the warm-up. And I don't want to use the word greatest in my definition. Who wants to try to fill this in? It's the what factor that does what to both numbers. So for this one, I'm looking for a size word. For this one, I'm looking for an operation word like adding or subtracting. I see India's hand. Who else has this? No one else wants to take a guess? All right, India, go for it.
The largest factor that multiplies,
You're really close. It's the other one.
divides.
That divides. And I'm going to be coming back to this definition over and over. And if you don't like the word largest, you can say biggest. I'm impartial. You can go with either way. So you need to be able to divide by that number. So for example, 12x, I can divide 12x by 2. You're allowed to do that because you'll get 6x. I can divide 12x by 4. I can divide 12x by 3. I cannot divide 12x by 7. That would be left as a fraction or a decimal. So the largest thing that I can divide 12x by is 4. Therefore, 4 is the greatest common factor of 12x, and, well, it might be the greatest. It's definitely a factor of 12x. All right, I'm going to come here. I'm going to be repeating this same little factoid of knowledge for the next 2 lessons, today, tomorrow, and on Wednesday. So if you've remembered it now, you can remember it and get XP later. Factoring in 2 steps. There are always 2 steps when it comes to factoring. The first step is the most commonly forgotten step, which is factor out the greatest common factor. So you can write out factor out the greatest common factor, or you can just abbreviate and just say GCF. Factor out the greatest common factor. All of today's lesson is factoring out the greatest common factor. We are only doing step 1 today. Step 2 is tomorrow and on Wednesday. Only doing step 1 today. So step 2, that's going to be the ninja star. Can you give me a quiet raised hand if you've ever heard of the ninja star? Vaguely? Okay, cool, thank you. All right, so let's talk about this step 1 today, factoring out the greatest common factor. There are 2 steps when factoring out the greatest common factor. You have the coefficient and you have the variable. The coefficient was exactly what we did for the warm-up. The warm-up of factoring out just a number. So coefficient, all I'm going to say here is factor out the number. So coefficient, let's say divide by the GCF. And that should just be a number. Before I move on to number 2, the variable, I want to show you in action what this looks like. So I'm going to skip down to example 1. So I have 2 different terms, 8x to the 4th and 4x to the power of 6. These 2 terms, I need to find the greatest common factor of their coefficient. Again, coefficient meaning that number out front, 4 and 8. What is the greatest common factor of 4 and 8? Quiet raised hand. GCF of 8 and 4. 2 hands. I see 1 hand with a card raised. I'll choose you, Colby. 4. There it is. So what I'm going to do here is I'm going to write the greatest common factor, and then I'm going to write my parentheses. And maybe give myself a little bit of room because I forgot to write the variable too. I'm going to write the variable right here next to the 4. But I'm factoring out a 4. What I'm going to do with each of these coefficients is I'm going to divide by the greatest common factor. The greatest common factor was 4, so 8 divided by 4, I'm going to write that as 2. I'm saying 8x, oh, yeah. And then 4 divided by 4 is 1, so I'm going to put a 1 over here. So far, so good. All right, this is where I'm going to have to do the variable. The greatest common factor of a variable. And I'm going to go back to, what was this, unit? It was a long time ago, but it's this rule right here. If I have x to the power of a divided by x to the power of b, this is equal to x to the power of something. Who can remember what that something is? I see 2 hands, both cardless. I'll give preference to people that have a card if they have it. That doesn't work. All right, India again.
It's going to be x a minus b.
A minus b, exactly. When I divide, and that's exactly what I'm doing right here, I'm dividing both numbers for the greatest common factor. When I divide, I'm really subtracting the exponents. So here, I have x to the power of 4. I'm looking at just the variables, x to the power of 4 and x to the power of 6. What can I subtract that will leave me, what is the biggest number that I can subtract from 4 and from 6? I can subtract 1, but I can think of an even bigger number than 1. What is the biggest number that I can subtract? Oscar? 2. That's even bigger than 2, though. You can subtract 2.5. Think of a whole number, Oscar. Keep going. Bigger than 2. What is the biggest number I can subtract from 4, the biggest number I can subtract from 6? And keep it positive, or 0. Keep it non-negative. Oscar, you want to give it another shot?
Someone else.
You can choose. Choose someone with a card.
Is it 4?
It is indeed 4. Thank you, Sam. So the greatest common factor is x to the power of 4. I can subtract a 4. So let me come back here, give Sam XP. Oh man, I've not been keeping track of this very well. So I forgot Sam, I forgot Colby, forgot Leo. I don't think Leo's gone yet. And I think India won again.
I went twice.
Okay, India 1 and 2. So India 1 and 2. All right, now what I'm going to do is I'm going to subtract the power. And this power, we'll make a note here, this power is the biggest. Wait, sorry, I don't know why I said biggest. It should be the smallest.
Really?
Sorry, smallest power. All right, so essentially what I'm boiling it down to is x to the power of 4 and x to the power of 6. Which of these has the smallest power? And it's clearly x to the power of 4. That is the smallest between these two, so that is going to be the greatest common factor. It's the smallest power. So 4x to the power of 4 is the greatest common factor. So first of all, box this. 4x to the power of 4. That is the greatest common factor. What's left over when you factor out this greatest common factor is subtracting the power, and I have x to the power of something, x to the power of something. When I do x to the power of 4 and I subtract 4, I'm subtracting 4. 4 minus 4 is 0. Anything to the power of 0 is shouted out. Uh-oh. Anything to the power of 0 is 1. So this is 2 times 1, or just 2. So I can do a 1 here if you want. And then I do x to the power of 6. So I'm doing x to the power of 6 minus this 4 that I factored out. 6 minus 4, you guys can shout that out as well. 2. So this should be x to the power of 2. I know it's complex. Stay with me. We're going to try it again. Maybe let's forget the second part. Let's just do only the greatest common factor. 36y to the 8, 9y to the power of 12. Someone find me the coefficient, and then I'll need a second volunteer to find me the variable. There's 2 parts for finding the greatest common factor. The coefficient, step 1. The variable, step 2. Martine, you got the coefficient?
9.
It is 9, yeah. Thank you, Martine. Why am I? There you are. All right, Martine told us the greatest common factor of the coefficient was 9. I need the greatest common factor of the variable. Go for it, Aurelio.
Whoa, I wasn't raising my hand.
You were raising your hand in a stretch.
Yeah.
I think you can do this, though, Aurelio. Which one of these is smaller, y to the 8 or y to the 12? Boom, Aurelio got it. Y to the 8, done. You choose the smallest one. That's as easy as it gets. Thank you, Aurelio. And Aurelio, you are right here. Oh, he's positive. He is on task. Good job, Aurelio. All right. 9y to the power of 8. That was the greatest common factor. It's that easy. You find the greatest common factor of the coefficient. You find the smallest power for the variable. Fifth of 5. How are we following examples 1 and 2? That's it. That's the first half of the lesson. Some people are not voting. I'm assuming you guys are zeros because you're not voting. All right. So, coming down here, distributing versus factoring. So, when I distribute 3x to the power of 4 into 4x to the power of 3, I'm multiplying these things together. Who can tell me what this is as an answer? 3x to the power of 2 distributed into each of these 2 terms. Who can distribute this for me? Martine?
12x.
Wow, fast. Yeah, 12x to the power of 5 and 6x squared. Thank you, Martine. Please stop. All right. So what I want to analyze here is the operations that I did with the coefficients and analyze the operations that I did with the exponents. I've already written this once in my notes. I'm writing it again to make it extra clear. The coefficients, what did I do? What operation did I do? This 3 and 4, what did I do to these 2 numbers to get to 12? Did I subtract them? Making this as easy as possible. Yeah, go for it, Leo. Multiply. Thank you, Leo. Write it down. Multiply Leo's coefficients. Leo's marble. Leo's XP. What did we do with the exponents? I had x to the power of 2 and x to the power of 3. I did what to get to the power of 5? What operation? Anna, you don't have your card in yet? Yeah, go for it. You add them. Thank you, Anna. Add those exponents. This comes from rules of exponents. There's Anna's marble. Okay, factoring means I'm going to be doing the reverse, the opposite or inverse operation. So instead of multiplying the coefficient, I'm going to do what with the coefficients? Oscar, write it down. Oscar is going to divide his coefficients. Thank you, Oscar. And there's Oscar's marble. All right, and then what am I going to do with the exponents? I'm not going to add, I'm going to do what? Easy XP, Lorea. Subtract. Thank you, Lorea. And there you are. All right. So I'm, again, going to find the greatest common factor. What is the greatest common factor of 12x to the power of 5 and 6x to the power of 2? First do coefficients, then do the variable. Who can tell me? Greatest common factor. I see 1 hand. I see 2 hands. Greatest common factor of 12x to the power of 5, 6x to the power of 2. Oscar, go for it.
6.
So you got the 6, you got the coefficient. You want to do the variable for us as well? It's just the smallest one.
2.
So x to the power of
X
2.
to the power of
There it is, yeah. So Oscar's got the greatest common factor. It is indeed 6x to the power of 2. Everyone write down Oscar's greatest common factor. Thank you, Oscar. Again, I'm going to have to factor that out. I'm going to start by writing my parentheses. If I had 2 terms to begin with, when I factor out the greatest common factor, I should still be left with 2 terms on the inside here. So I'm going to divide everything by 6x to the power of 2. I have what I'm supposed to do written underneath here. I have 12x to the power of 5. It is now what? 12x to the power of 5 divided by 6x to the power of 2. I see one hand. I'm going to do what with the coefficients? 12 and 6. I'm going to do what with those coefficients? I have x to the power of 5 and x to the power of 2. I'm going to do what with those exponents? Give me the answer when I factor out a 6x squared for the first term. I still only see one hand. There's no other hands?
1 plus 1, 2.
Oh, I see. Okay, 2 hands. Martine, go for it. It is 2x to the power of 3. Thank you. All right, Martine is in. All right, this second one is going to be a little bit trickier. 6x to the power of 2 divided by 6x to the power of 2 is what? India, go for it. 1. Notice that I'm also doing something that I haven't explicitly stated. If this sign was a plus sign, this sign is also a plus sign unless I factor out a negative. That will be on Wednesday. But for now, just copy down the sign in between. If it was a plus, leave it a plus. All right, let's see if we can do some more of these factoring problems. Everyone is finishing writing this down. All right, we are on to example 3. All right, there are 2 steps when I'm factoring out the greatest common factor. Factoring out the coefficient and factoring out the variable. I need someone to do the greatest common factor first. What is the greatest common factor of these 2 terms? I see Samantha's hand. Who else has a hand? I see India's hand. Who else has a hand? Lorea's hand. All right, Sam, go for it.
Is it
2,
two?
you got the coefficient correct, and then the variable is going to be a to the power of?
4.
There it is. Yeah, Sam has 2a to the power of 4. Everyone write down Samantha's greatest common factor. 2a to the power of 4, and then set up your parentheses. Thank you, Sam. Getting closer and closer to that party. All right, since we found the greatest common factor, Sam found that for us, I now need to do these 2 operations to find the inside. If I had 2 terms on the inside, I should have 2 terms. Someone tell me what that first term is with a quiet raised hand. What is the first term? I see one hand. I see Anna's hand. Who else has a hand? Who else knows how to divide or factor out that 2a to the power of 4? I see India's hand. Go for it, Anna.
4x to the power of 3.
Ooh, careful. So first do 6, and then I'm going to do this operation with a 2. 6 divided by 2.
3x to the power of 4.
So 4 minus 4 is 8 to the power of 0. So anything to the power of 0 is done. So it's just 3. Yeah, thank you, Anna. And Anna has her marble in. So it's just 3. And then I'm going to copy down the sign. It was a plus, so I'm going to copy down the plus. Now I need to do 8a to the power of 7 divided by 2a to the power of 4. Again, I'm going to divide the coefficients, subtract the exponents. Someone tell me what that is. Quiet raised hand. Who has this? Chewy, Jaden, I haven't heard from you guys either. You're in the back. (8a to the 7th) divided by 2a to the 4, because I factored out that 2a to the power of 4. Who has this for us? India, go for it. There it is, 4a to the power of 3. Thank you, India. That is my final answer. I don't even need to box it because that's the only thing that I have here. If I have a bunch of scratch work and then an answer, then I would box it. Here, I'm fine. Just 2a to the power of 4 times 3 plus 4a to the power of 3. Thank you, India. All right. Give me a fist of 5. How well did you follow example 3? Because I know that some people can give me high scores even though they didn't participate. Nice. Those are some pretty high scores. Thank you. All right. So I think for the rest of these, oh yeah, so I'll give you this hint too. These 3 examples you're going to be solving in your groups right now. One of them cannot be factored, and that happens in life. In fact, most polynomials can't be factored. For the tests, you'll see one that can't be factored, but most of them will be able to be factored. So what I want you to do right now for example 4, 5, and 6 is work within your groups, work with people next to you, and factor out the greatest common factor. Good luck. We are back. Example 4, quiet raise hand. What was the greatest common factor? Free XP. Emily, go for it. 5. There it is, 5b to the 100. Thank you, Emily. And you can turn in your card too if you still have it. So Emily, you are now in, and there's your marble. What goes on the inside of the parentheses? I need 2 volunteers, 1 for each term. First volunteer. Leo, go for it. 7b. 7b to the what? The power of 2. Perfect. That's the first term. Thank you, Leo. And what is the second term? Caroline. -4. There it is. Thank you, Caroline. That is the final answer. All right. Example number 5. Greatest common factor was what? Martine. There it is. 10c to the power of 32. And then I need 3 different volunteers to do the inside after I give Martine his XP. All right. The first term, Chewy. There it is, 3c squared. Thank you, Chewy. And there's your marble. All right, next term is Chewy again. Plus 6c. Thank you, Chewy. And marble again. All right, and the final term is what? Anna, go for it. -10. Yep. There is the answer on a marble.
Can I go to the bathroom?
Yeah, that's a good time. And finally, example 6. What was the greatest common factor for number 6? Quiet raised hand. India. 1. There was not a greatest common factor. And again, I told you one of them can't be factored. That's your final answer. You don't have to do anything to it because there was no, I mean, 1 technically is the greatest common factor, but you can't do anything to this one. So that is your final answer. All right, does anyone have any questions on examples 4 through 6? Or anything in the lesson? No questions, no questions? All right, then you can write your summary. The main thing to take away from the summary is when you factor, you do this, or you do these operations when you're factoring, and there are 2 things that you're doing for the greatest common factor. You do the coefficient and the variable. So those 2 things probably should be in your summary. If you want to also add the fact that there are 2 steps for every time you're factoring any quadratic, it's going to be GCF and Ninja Star. That would also be a nice thing to add to your summary. You guys should all have the homework, if not already done by now. Thank you, India, who just turned in your homework. And that concludes our lesson.